Okay, we are continuing with naming ionic and covalent compounds and determining which is which. So for worksheet number 2 of naming both ionic and covalent compounds, we are going to start with determining what type of element it is before we determine how we're going to name it. So if we look at the periodic table, boron is here, bromine is here. Those are both nonmetals, which means we are going to use prefixes because they're both nonmetals, and so that means they're going to form a covalent bond. So, boron is our first element. There's only one, so we don't have a prefix for the first one if it's 1. And then 3 means tri, and then the element is bromine, and so that becomes bromide. Number 2, calcium, if we look on the periodic table, is right here, which means it's a metal. And SO4 is the polyatomic ion sulfate. Now, the fact that it's a metal means that it's an ionic compound. A metal with a nonmetal or a cation with an anion means it's going to be an ionic compound, which means we are not using prefixes in this case. So we're just going to write the cation and then we're going to write the anion. If you look on the periodic table, you know right away that the charge of calcium is a +2. That means we do not need Roman numerals for this one, such as calcium sulfate. Okay. C2Br6. C is there, Br is there. You'll notice that those are both nonmetals, which means that we are going to use prefixes because it's going to form a molecular bond. It's going to form a covalent bond. 2 means di. C is carbon. 6 is hexa. And then Br is bromine, but that becomes bromide. Number 4. Notice I look at the periodic table for every single one of these, because you can't figure out how to name it unless you do that. Chromium is here. CO3 is a polyatomic ion for carbonate. Now, knowing that chromium is there, you cannot look on the periodic table and tell me what the charge is. That means we're going to have an extra step of determining what the Roman numeral is to tell people what the charge is. And then the anion's carbonate. So chromium something carbonate. The parentheses are right here. We're going to uncross it to determine its charge. So that's a +3. There's no number down here for carbonate, so that's going to be a -1. If you look up carbonate, you'll find, however, that carbonate is supposed to be a -2, not a -1. So that means we need to multiply both of these by 2. So chromium actually becomes a 6. Alright, Ag3P. Ag is here, P is here. That means we're going to form an ionic bond because of the fact that silver is a metal and phosphorus is a nonmetal, so silver is going to give away its electrons to the phosphorus. Silver is one of the 2 exceptions of the rule. If you look at silver, you may think that you don't know what the charge is because of the fact that it's in that middle area. However, silver is always a +1, and zinc is the other exception, it's always a +2. That means that when you're writing it out, you don't have to write the Roman numerals like we did up here for chromium. So it's just simply silver, and then P is phosphorus, and it becomes phosphide. Right, number 6. Iodine is here, oxygen is here. That means that they're both nonmetals. which means that it's going to form a covalent bond, which means the electrons are being shared. Not like a cation and anion, where the cation gives away its electrons to the anion. That means we're going to be using prefixes. Okay, so we have iodine. Notice it's a 1. If the first one's a 1, you can leave it blank. You don't have to put a prefix there. Then we have 2 oxygens. 2 is di, and oxygen becomes oxide. Okay, VO2. Vanadium is here. Oxygen is here. The fact that you have a metal and non-metal means that we're going to have an ionic compound here. So that means we have to write the cation and the anion. The cation is vanadium, and the anion is oxygen, which becomes oxide. Now, if you look in the periodic table, you should ask yourself, can I determine the charge just by simply looking on the periodic table? If the answer is no, which in this case it is no, that means we need to have a Roman numeral in here. That means we had to figure that out by looking at the chemical formula, by uncrossing it. That 2 down here makes the vanadium a +2, and the oxygen is a -1 because there's no number down there. If you look on the periodic table, however, oxygen is here, and that's in the -2 row, which means that we have to multiply both sides by 2 because it must have been reduced when it got put in its formula. So that means oxygen is a -2, which is what it should be, and it means that vanadium is actually a +4. Okay, lead and sulfur. Lead is right here, which means it's a metal. However, it's a metal that when you're looking at the row, you don't know what the charge is, even though it's not in the middle, which means you do need Roman numerals. In the name. So, Pb is lead. We're going to leave a space for the Roman numerals, and sulfur becomes sulfide. We're going to uncross it to be a +1 and a -1. Sulfur, when you look at it, it's right here. It's supposed to be a -2, not a -1. Because of that, I'm going to multiply both sides by 2 to make sulfur what it's supposed to be, which means lead is actually Roman numeral 2, not Roman numeral 1. Alright, CH4. To use the rules that we've been using, technically this is an organic compound, and so it would be methane. Because they have, carbons and hydrogens have their own little set of naming. But to use the rules that we're using with the ionic and covalent, we're going to look at the fact that carbon's here and hydrogen's here. Even though hydrogen's on the left-hand side, it's actually still considered a nonmetal. It's just on that row because of the fact that it gives up an electron when it reacts. So with this one, it's going to be a molecular compound, which means we're going to be using prefixes. The first one's 1, so we don't use a prefix for that one, so it's just simply carbon. And then 4 is tetra, and the hydrogen becomes hydride. And the last one for this video is N2O3. Nitrogen is here. Oxygen is here. They are both nonmetals, which means that we're going to be using prefixes. So, N is nitrogen. 2 means di, so it's dinitrogen. And then 3 is tri, so it becomes trioxide. And that's it. So that's answers to numbers 1 through 10 on the naming both ionic and covalent compounds 2 worksheet.